Welcome. Today I'm going to provide an improvised solution to the art gallery problem. First, let's look at the problem statement. The problem is to place the minimum number of guards in an art gallery so that every area of the gallery is completely guarded. The entity for guarding may be guards or sensors. It should be something that can communicate in this place. As a matter of convention, I'm choosing guards here. And one more thing that is to be noted is that we can place guards only on the vertices and not inside. This is a condition that is given for the problem. This art gallery problem is a funnier way of representation of a surveillance problem. In general, galleries will have a defined polygonal structure. But what if the polygonal area that is given for surveillance is irregular, which may be something like this? Our solution must cover this problem too. There is already a solution given to this problem by a mathematician named Stephen Fisk. He proved that n over 3 guards are enough for guarding any polygonal area with n vertices. In order to prove this, he used the method of coloring the vertices of the triangulated polygon. This means that the polygon must be triangulated. So now we come to a question: what is triangulation? Triangulation is the process of splitting of a polygon completely into triangles. As a matter of fact, any polygon can be completely split into triangles. Now coming to the existing solution. Let's take the irregular polygon that we saw earlier. The first thing that we have to do is triangulation. After triangulation, the polygon will look like. Then further we have to color the vertices. We have to color the vertices in such a way that no two vertices of a triangle have the same color. This way we can ensure that every triangle in the polygon will have three distinct colors in its vertices. After triangle will look like this. Any three colors can be given to the vertices. I have given red, blue and yellow colors to the vertices here. There are 5 red and blue vertices and 8 yellow vertices. Now we have to pick the color which is less in number. Here we can choose blue or red. I'll go for red. If we choose the red ones, the resultant polygon will look like this. This is the solution that is given by following the method that is given by Fisk. But we are not done yet. We can see that there is a problem here. The guards are not optically connected. This means the guards cannot see each other. These two guards are optically connected and these two guards are not. We have to find a solution to solve this. For that, we'll take the triangulated version of our polygon. Then let us place a point inside each triangle. So now our polygon will look like this. Now we have to connect all these points in such a way that there is a connection between the first and the last point in the polygon. Here, this is the first point and this is the last point. So after connecting them, we will get a figure like this. As I told before, there is a continuous connection between the first and the last point. We can see that. It goes like this. If we closely examine the lines that we drew now, we can see that it looks similar to a tree structure. Now what we have to do is, we have to group all these points in trees with overlapping. Like this. After grouping the entire set of points in trees, our figure would look like this. The concept now is that for every overlapping triplet, the vertices of the triangle that are common to the points in those triplets will serve as the resultant vertex where the guard will be placed. If we follow the above concept and mark the vertices, we will finally get a figure like this. Here we can see that these two are overlapping points. The vertex that is common to these two triangles has been marked here. This same procedure is followed for the other markings also. So now our final solution will look like this. The red points are the places where the guards will be placed. we can clearly see that this positioning of the guards will completely have the area of the polygon under surveillance, and also the guards are visibly connected. The blue line here represents the optical line of visibility. As a matter of fact, the number of guards required if we follow this method will be approximately n over 2 minus 1. In our case, the number of vertices is 18 and the number of guards that we require is 5, which is nearer to 8. Thus, I complete my solution here. Thank you for your patient listening.